Bienvenidos, Ushamadid, and welcome Anne Arundel Community College learners from the CTS-130 Section 402 course for the spring 2021 semester. This is the Cisco Networking Academy's Introduction to Network version 7 course, and in this packet tracer tutorial, we're going to be taking a deeper dive look at activity 2.7.6, where we're going to be implementing basic connectivity to a set of switches. Now, in our previous activity, 2.5.5, we saw how we would configure some basic settings. So now we're going to build on that. So here is activity 2.7.6. As you can see over here, we have our addressing table, which is going to be very important for this activity because the type of basic connectivity that we're going to be implementing is what you would refer to as remote connectivity. In other words, we're going to be using either Telnet or SSH to connect from the PC to the switch. And in order to do that, we need to have IP addresses assigned. And you can see here, we have our switch 1 and switch 2 IP addresses, along with the IP addresses of PC 1 and PC 2. Now, you'll notice that it says that the interface that we're connecting to is VLAN 1. And in the previous video, I had commented that this is what's commonly referred to and what is a switched virtual interface, or a switch virtual interface. And it's a layer 3 interface that's not a physical interface on the switch. It's a layer 3 interface, and by layer 3, we mean the network layer. It's a layer 3 interface to which we will assign an IP address. And then a PC that is plugged in and connected to the switch in the same VLAN can then use that switch virtual interface IP address to then connect to that switch remotely using Telnet or SSH. So let's go ahead and dive in. We're going to perform basic configuration again on switch 1 and switch 2 to reinforce and reiterate some of the things we did in activity 2.5.5. We're going to configure the PCs with their IP addresses, and then we're going to configure, they refer to it here as the switch management interface. And yes, we will be managing the switch via this interface, but it is referred to as a switch virtual interface. Again, it's a layer 3 interface that doesn't actually physically exist on the switch. It's just virtually there running in software, and the switch will listen for connections that might be coming in remotely that want to be using that IP address, that switch virtual interface, the SVI, to connect into that switch. So here are the instructions, and let's go ahead and dive into this activity and start our conversation about some of the things we're going to want to be doing here. So we're going to perform our basic configuration. So we'll click on switch 1, and remember, when I click on the switch in Packet Tracer, it's as if we are connected to the console port. Remember, a console port is typically on the rear of a switch. Sometimes it'll be on the front, but typically on the rear of a switch, into which you can connect an RJ45, or it's referred to as a rollover cable. And sometimes in the Cisco world, people will say, oh, the Cisco blue cable, because they're this really nice light blue color, which is very similar to the highlighting I have here. So that is how we're connecting when we click on the device here. However, when I click on the PC and I pull up the command terminal on the PC, that is when we're going to remotely connect to the switch, because we are not directly using that console port on the back. So remember, we're in user exec mode here. And user exec mode only allows me to do a few things. We want to transition in order to configure the switch. We want to transition to privilege exec mode. And to get into privilege exec mode, which is like that super user root supreme being mode where I can do anything to the switch that I would like, we use the enable command. Or you could simply just type EN from user exec to get into privilege exec. So here I am in privilege exec, and now it's from here that I can go ahead and perform configuration tasks. But to do that, I need to issue the configure terminal command, or as we saw, simply conf t. That moves me into global config. So the first thing it wants us to do is says enter the correct command to configure the host name as switch 1. And so we simply enter in host name S1. And I said switch 1, but it's just S1. And so that's our host name is just S1. Now, you're also going to want to enter in no IP domain lookup. Remember, that command, when in privilege exec mode, if I was to enter in a command and typo that command, it would try to translate it using DNS because it thinks it's a host name that we have entered in. Because if the switch can't figure out what command you're typing, because again, we've got a typo in the command, then it's going to try to translate that command as if it was a host name. If we came over to switch number 2 and I went into privilege exec and I typed in that as my command, and obviously it's a typo, you can see it's trying to translate that using DNS. We don't want that. We don't want that to happen. If I enter a typo, I simply want it to tell me, hey, I can't find that command, and oh, by the way, I'm not going to do a DNS lookup. So we say no IP domain lookup. And we're not going to get any points for that, but this is a very valuable command. It's going to save you a lot of time from having to sit and wait for either this to finish or for you to remember that you hold down Control, Shift, and the number 6 to get out of that. And you can see name lookup aborted. So back over to switch number 1, that is step 1. Now we're going to configure the console and encrypted privilege exec mode passwords. So it says use Cisco, and you can see here they're not giving us a lot of the commands, right? They're expecting that from our previous work in activity 2.5.5 that we have practiced a little bit and that we're confident on the commands that we need to use. So let's go into line con 0. That is our console line. Remember, if you wanted to say show run, what's going to happen, or show running config, what's going to happen if I hit enter here? Yeah, we're going to get an error. Remember, we are in the global configuration line configuration submode. And so I can't run commands that I would normally run when in the privilege exec mode. So how do I do that? Do show run. Precede the command that you would normally run in privilege exec mode with the keyword do. And this is an undocumented feature. And so we would go all the way to the bottom, and here is line con 0. So now it's asking us to use the password Cisco. So I'm going to say password Cisco. And then what other command do we need to make this work? Exactly, the login command, which informs the console line that if someone's trying to log in via the console line directly connected to the router or to the switch, that I'm going to prompt them for the login password, which in this case is Cisco. Now, if you hit the up arrow, it'll pull back previously run commands in this configuration mode. So maybe I want to check and see, did that command actually get applied? And there it is, password Cisco, and then the login command. So that takes care of the host name and the password. Let's use class for the privilege exec mode password. Now, remember, it's interesting here. It's not asking for the secret. It just simply says privilege exec mode password. And here's where you need to be careful. So let's exit out to global config mode, which is where we would configure the enable password. You'll typically hear it referred to as the enable password, because this is the password that the user will be prompted with when they go to increase their privileges and move from user exec mode to privilege exec mode. And the reason they say it's the enable password is because the command that you enter to move from user exec to privilege exec is enable. So let's watch our completion percentage in the lower right-hand corner, which is currently at 13%. And let's see if I say enable password, if this is what they're looking for. Because, again, it says use class for the privilege exec mode password. But do they want me to use the password option, or are they expecting me to use the secret option? So let's go with password first, and let's see if we receive any points. So I say enable password class. Now, you'll notice we did not receive any points. And the key is right here. And again, I walked us into this intentionally. The key is right here. Configure the console and encrypted privilege exec mode passwords. So then down here where it says use class for the privilege exec mode password, we want it to be encrypted. So I've entered this command, and it's okay that it's there, but we don't want it there because obviously it's going to show the password, and even if I was to use the service password encryption, we'd end up with a type 7 version of that password, which someone can cut and paste. So we're going to remove it by simply saying no. If you want to remove a command or a setting that you've entered, you can say no, and then that command that was used to enter that setting. So I'm going to say no enable password, and I'll pull class out of there. So I'll say no enable password. And so if I was to say do show run, you would see that we don't have the clear text password for the console, or for, I should say, for the privilege exec mode. So let's get the right command entered in here. So I'm going to say enable secret class. Now, we got 5 percentage points for that. And we now have an encrypted password to get into the enable mode, right? Or into that privilege exec mode, that root super user mode. And so that's a good thing to do, is to protect the password for enable mode or privilege exec mode. Again, you'll hear it referred to as enable mode a lot because that's the command that you use to get into privilege exec, is enable. So how can we verify both passwords were configured correctly? Well, that's easy. I can say do show run. I see that's encrypted, and I see my password right there is Cisco. Now, what else could we do? Yeah, I could say end, and that puts me back in privilege exec. I could have said exit as well, and then I'll say exit to log off. So now I'm going to hit enter, and I want to get logged back in. So let's go ahead and put our password Cisco, and that is the console line password, and it allows me to get logged in into user exec mode. Now let's move to privilege exec mode using the enable command, and does the password class work? And it does. So that's another way that you could check to make sure that the passwords were configured correctly, and that's probably how they want you to do it, because with the encrypted password, maybe there's a typo that you put in there. You can't tell by looking at that ciphertext. All right, so use an appropriate banner text to warn unauthorized users. Well, let's get back into global config, and we'll say banner MOTD, the message of the day. And we're going to enclose it in quotes here. Authorized access only. Violators will be prosecuted to the full extent, and I think it's the fullest extent of the law, or the full extent of the law, period. All right, so that is our banner message, right? And that's what someone's going to see when they go to log in via the console line or remotely via the VTY lines, those virtual terminal lines. Save the configuration to non-volatile memory. Now remember, if I try to say copy running config to startup config here, what do you think is going to happen? Oops, sorry, startup config. What do you think is going to happen? We're going to get an error because remember, we're in global config mode. So could you do this? Could you proceed this command that you would normally run from privilege exec mode with that keyword do? And the answer is yes. Remember, commands that you can run or that you would run from privilege exec mode, you can simply run those in any sub-configuration mode if you precede them with the keyword do. This is going to save you a lot of typing, and I mean a lot of typing. And there we go. So we've saved the configuration off. Now, the other command that I can use to save my configuration is do write memory. And you'll notice I'm hitting tab, but it's not completing the command because I'm not in privilege exec mode, which is where the context-sensitive help, which is what that tab key, that command completion functionality would offer me. So again, you're going to have to know the command that you're going to run if you're using do from global config or sub-configuration mode, and that's a command that you would typically run from privilege exec. So write memory is the full command, or you can just say, I usually do rymem. That will save the configuration as well. So let's repeat steps 1 through 5 for switch 2. And again, and you can see there, right? I went to hit return, or the enter key, hit the apostrophe, and what does it think the apostrophe is? I love to refer to this as a fortuitous failure. It's something that you do wrong, and then you realize, oh, yeah. So this is why I put no IP domain lookup on the switch in global config mode, so that I don't end up with that happening. So let's get into global config, and let's type in the host name first. It's going to be switch 2. Again, no IP domain lookup, and that is going to prevent what just happened with the apostrophe that I entered. And let me take a quick look back here and make sure we get everything. All right, we've got the host name in there. So let's add the passwords in here, and I'm going to actually give you another command, another value add command that you're going to want to add to the console line. So let's go ahead and say enable secret is going to be class, and let's get into the console line. So line con 0. Now remember, we're going to set the password to Cisco, and we're going to say login to make sure, and that's going to be a command that you might forget here first time through this activity because they don't tell you to say that, right? Or they don't tell you to enter that on the console line. The other command that you're going to enter, that you're going to want to enter, is logging synchronous. Now, you might think, well, that's a pretty odd command to enter on the console line. What value add is this going to give me? Well, what this command is going to give you is, while you're doing configuration, I'm going to leave it on switch 2, but I'm going to leave it off on switch 1. And so we'll see what happens. So what this command does or facilitates is when you are making configuration changes, sometimes you will see switch messages, syslog messages, come to the console that look like this. Line protocol 5, and that's a notification level log message, and it says up down. So the line protocol on interface VLAN 1 changed to up. Now, if you happen to be in the middle of typing a command, this will come up and completely obliterate the command that you were typing. If you do not have logging synchronous set, it is not going to put you on a new line with where you were at in entering that command. It's going to leave it all jumbled together on the command line, making it next to impossible for you to see or decipher where you were at in that command, which typically leads to you hitting the backspace key a whole bunch, or hitting enter and looking at an error message, or possibly entering in the wrong command. So logging synchronous is an extremely valuable command to have on the console line. And again, we're going to see what happens. So we type in logging synchronous. Again, no points, but that's beyond our concern here, right? It's not about the points. And I know that for new learners, that's sometimes difficult to absorb. It's not about the points, right? It's about learning how to do things that are going to help make our jobs easier and us more effective. Sure, there's a grade out there, but again, It's about learning the technology. So let's verify the configuration here on switch 2. Well, I'm going to go ahead and say end and exit, and I'll hit enter. We get the password. It should be Cisco. I'm in user exec mode. Can I get to privilege exec mode with the enable command, which is class? All right, so those settings are all taken care of. Now we're going to configure the PCs. So how do we do that? Well, we click on PC 1, and let's give ourselves a little bit more room with which to work. And you can see here they have an IP configuration tab, right? Very convenient. And we're going to enter in our IP addresses. So 192.168.1.1 for PC1. Now I'm going to hit the tab key, and you'll notice that it auto-magically fills in the subnet mask. But the value that is being filled in here is based on the value we entered in for the IP address based on the class of what that IP address would be. In other words, the subnet mask in dotted decimal notation will be entered in for us auto-magically based on the class of the address we enter in. So in other words, if I had said, instead of 192.168.1.1, 10.0.0.1, and let me back that out, you can see that it auto-magically puts in the dotted decimal subnet mask for a class A address. If I had entered in 172.16.0.1, it enters in the dotted decimal notation for a class B IPv4 address. And so when I enter in 192.168.1.1, it auto-magically enters in the dotted decimal notation for the subnet mask, which would be for a class C address. So remember, when we get into subnetting, these values you may have to manually change. And so you can see we did get some points for that, and there is our subnet mask value, but it was auto-magically put in there for us. So repeat steps 1A and 1B for PC2, keeping in mind that the IP address for PC2 is not the same. So this might be a little misleading when they say repeat steps 1A and 1B for PC2. You may come up here and say, oh, okay, so then I enter in those values. No, remember, if we come to the addressing table, the address for PC2 is, the last octet is 2, not 1. So we'll come over here and we'll enter in 192.168.1.2. And as I had explained, we auto-magically have our subnet mask entered in for us. Okay, so it says click PC1, close the IP configuration window with this little X right here, and let's open up the command prompt, which is right here. And now we're on the CLI, right? Or that DOS prompt, as sometimes you hear it referred to. Okay, so let's ping 192.168.1.253. So first, what are we pinging? Or what are we trying to ping? We're trying to ping switch 1, because up here, it says that that is the IP address for switch 1. That is the switch virtual interface for VLAN 1. And remember, a new switch that you take out of the box, a Cisco switch, all of the ports are in VLAN 1. VLAN 1 is the default VLAN. So when the PC is plugged into the switch, and when the switches are plugged together, and PC2 is plugged into the switch, all of those ports are in VLAN 1 on the switch. And remember, we haven't talked about trunk links yet. This is not a trunk link, okay? That is just simply a link between the two switches, which is in VLAN 1. And so keep that in mind. And so all that link is doing is it's extending VLAN 1. And remember, a VLAN is a subnet, is a broadcast domain. So we're just extending VLAN 1. And if I was to pull my drawing tool up here, if I was to add another switch over here, and then another PC, this would all be VLAN 1 by default. We'll add our PC. And then the same thing, I add one over here. We put a new switch in and a new PC, and by default, everybody is in VLAN 1 in terms of all of the PCs, and all of the inter-switch links, the links that run between our switches, are also all in VLAN 1. And keep that in mind, because this kind of becomes a little confusing for learners once we start to talk about trunk links. And remember this about a trunk link. A trunk link, by default, will allow all VLANs to cross it, right? And so that's the difference between a trunk link and simply a link that we just plug in between the two switches that is only a single VLAN, right? All right. So enough about that. So back to this ping command. We run this ping command, and this ping command is not going to work. And I can confidently tell you that it's not going to work because we are pinging an address for a switch virtual interface. Remember, the layer 3, that network layer. And at the network layer, it's all about the IP address, whether it's IPv4 or IPv6. And so that switch virtual interface, that we want to have this IP so that anybody like PC1 and PC2 who are plugged into ports on these switches in VLAN 1 can remotely administer the switches. And so were we successful? No. The reason that we were not successful is because those IP addresses, those switch virtual interfaces, which the activity is referring to as a switch management interface, and that's okay. You think of those terms as being synonymous, an SVI and an SMI, although you typically don't hear SMI, you're going to hear SVI, that we need to configure these things, right? And this note right here is great, okay? Switches can be used as plug-and-play devices, and we've seen that because, again, if everything is in VLAN 1, I can just plug in a whole bunch of things, PCs, servers, access points, right? I can plug in things into the switches and everything is in VLAN 1, and so then everything will work, and that's great. So, if this is the case, how would we configure the switch with an IP address so that we could manage it? Because we're not connected via a console port, and it's through a switch virtual interface. So let's pull switch 1 up here, and here we go. We get to take a look. There's our message of the day. Here's the password prompt for the console line. The password is Cisco. We're now in user exec mode. Let's go ahead and get into privilege exec with the enable command. The password is class. Let's get into global config because now we're going to be configuring things on the switch. And here is where we go into interface, VLAN 1. This is how we get into the switch virtual interface. This is not how you create a VLAN. And this will be a confusing concept initially. Remember, when you say interface, VLAN, and the number, you are going into the layer 3 switch virtual interface for that VLAN. This is not how you create a VLAN. And those are two, let's think of those as mutually exclusive tasks right now. So here we're interested in the switch virtual interface, the layer 3 virtual interface running in software to which we are going to assign the IP address 192.168.1.253 with a dotted decimal subnet mask of 255.255.255.0. For now, just know that this is referring to something that we call a /24. And when I say slash, it's the CIDR the classless interdomain routing representation or notation for what this subnet mask is in dotted decimal notation. In other words, what we're saying is that an IP address is 32 bits, each octet is 8 bits, and if all of those bits are being used, which they are here because the value is 255, you would say that all 8 bits are being used in the first 3 octets, and so 8 plus 8 plus 8 is 24. And you'll hear this referred to as a /24. And this is the notation that is commonly used in network engineering administration, whatever you want to say, in networking, right? And this is referred to as the CIDR notation, C-I-D-R. And again, we'll get to subnetting soon, but keep these things in mind, right? And again, we didn't use any of the bits here, which is why we have the 0. If we were using some of the bits here, then the CIDR notation would be a little bit different. But for right now, remember, that's why we say /24, because the first 24 bits are all being used to represent the network. All right, so we've got our IP address entered in here. Let's hit enter. And what if I wanted to type another command, and I'm waiting here. I'm hoping that, it wants to, okay. So we're going to have to say no shutdown. So no shutdown is how you would bring the interface up. Now, sometimes it might come up auto-magically for you. Other times you're going to have to say no shut. So a good practice is to always say no shut, which means no shutdown. Remember, in Cisco parlance, the Cisco language, we wouldn't say, in order to shut it down, we say shut down. In order to turn it on, you don't say turn on. You simply enter in the no version of the command to do the opposite. So if shutdown was to shut the port down, the switch virtual interface down, in order to turn it on, I say no shutdown. Now watch what happens. I'm going to see if I can quickly, and you can see there. So now I'm typing this command, right? And look, we've got these syslog messages that popped up on the screen, but I didn't get my prompt back. So now maybe I don't know where I'm at in the command, and maybe this output is jumbled into the command. And again, sometimes that is going to happen. Again, you might not know where you're at on the command line, and so then you end up hitting the backspace or the delete key, right, to try to get all the way back. And then if you hit enter a few times, then you get the prompt back. Logging synchronous would give me the prompt back auto-magically. All right, so now we're going to say exit. And it says, why do you enter the no shutdown command? And we're entering the no shutdown command to bring that switch virtual interface, that virtual port that's running in software, that anyone in VLAN 1 can try to SSH or Telnet or ping that address. That's why we say no shutdown. So it says use the information in the addressing table to configure switch 2 with an IP address. So let's go ahead and quickly configure switch 2. Whoops, sorry. So Cisco, and then we'll get into privilege exec mode with class. We're going to go into global config, interface VLAN 1, where I'm going to say IP address 192.168.1.254. Let me double check that. Let's make sure. Yeah, .254. And so we'll configure the IP address, and it's a /24, right, where 255.255.255.0 represents our subnet mask in dotted decimal notation, and then we're going to have to say no shut. Now, look at the difference, and hopefully you caught that. If you didn't, rewind a little bit. Where were we left on switch 1 when I typed in the no shutdown command? We had no prompt, and then the text I was typing showed up right below this message. But with logging synchronous on the console line, it puts me right back onto the prompt. And if I had typed in a command, this is where we would be placed. So we would know exactly where we were at in that sequence of events. Without logging synchronous, if you get these log messages that pop up on your screen when you're connected to the console port, they can mess up your sort of recognition of where you're at, right? Your, what's that? There's a word I'm looking for here. Your orientation as to where you're at in the command, it's going to get messed up. So logging synchronous, great command to put on the console port. Okay, so we configured switch 2. So verify the IP address configuration on switch 1 and switch 2. So here's this command that I talked to you about earlier. Now, remember, do show IP interface brief. Just precede the command that you would run from privilege exec mode with do. And there it is. And we come all the way down to the bottom, and here is our information for our switch virtual interface for VLAN 1. Let's do the same thing on switch 1. Do show IP interface brief. Come all the way to the bottom, and there is our IP address for VLAN 1 on switch 1. That's switch virtual interface. It says you can also use the show running config command, and you can, right? I can say do show run, but boy, does this not take a lot longer to get down here. And then we're seeing all this output. In fact, you could say do show IP interface brief, right? And remember, it shows us all of that. But what if I only wanted to include lines that had VLAN, that string VLAN on it? So there's another shortcut that you can use. You can pipe the output. In other words, send the output, which is all of this stuff, right? Send it into this little filter here, which says include only the lines that have that string VLAN. And again, it doesn't even have to have VLAN 1. I could even say VL. And you can see it's only showing me lines with VL. If you wanted to see the lines that had interfaces, virtual or physical, that were up, you would simply say include up. And there's the ports, again, physical or virtual, that are up, that we can assume have something connected to them and that are being used. If you wanted to see only the ports that were down, include only the lines with down. And again, that's going to show us a whole bunch of stuff, but it filters out all of the things we do not want to see. So remember this little trick right here, because it can save you a whole lot of time. All right, so save the configuration. So how do we save them? Well, I could type exit, right, and say, whoops, copy running config to startup config. And then we assume it's the startup config. And that writes the running configuration is now saved off into the startup configuration. The other way that we could save the config is to say write memory, right? Or just WR mem. And I think, in fact, you could probably write WME would also work. Again, you can shrink it down as long as there's no other command, right? So you can see no other command begins with W. So I could say W, and then what if I say WM? Yeah, that works, right? So I usually just type write mem. So, but you can see we can abbreviate things. So we save the configuration of switch 1. Let's come over to switch number 2. I could say do copy run start, right? So I can abbreviate the command, do copy run start, and it knows that I mean the startup configuration. And you can see we got 5 points for that. I could say do write mem. And that would do the same thing as copy running configuration to the startup configuration. So we've got some questions here. Which command is used to save the configuration? In RAM, remember that random access memory, that is volatile. But there's a little chunk, right, that we call NVRAM, which is non-volatile, meaning we reload the switch. If we've saved our configuration, all those changes will be there. If you don't save your configuration, any of the changes that you have made since the last time you saved it will be lost if the switch powered off, you reload the switch. All right, so let's verify our network connectivity. Now we've got 95% over here, so hold on one second. Let me see if they're copy running config, startup config. I'm trying to see, Packet Tracer scores things interestingly sometimes, and I want to make sure. So it says we're missing 5%, but we'll see what comes. We'll see what comes of that 5% there. All right, so now let's verify network activity or network connectivity. So can I ping 192.168.1.253? Remember, we're all in the same VLAN, VLAN 1. Now, this first timeout here is typically due to an ARP packet. And ARP is ARP, Address Resolution Protocol. And what that means is, I'll give you the abbreviated explanation, is we know the IP address we're trying to get to, but I don't know the layer 2 information, the data link layer information, specifically what is the most important PDU at the data link layer, layer 2, it's the MAC address. And so I'll send an ARP packet out that basically says, hey, I'm trying to get to 192.168.1.253. Who owns this layer 3 address? If it's you, give me your layer 2 address so that I know how to get to you. In fact, if I say ARP-A, you can see that there is the physical address. That is the MAC address of the switch with that IP address. Now, you'll notice we don't have the information in here for the other switch, 192.168.254. Now, I'm assuming that Packet Tracer is not going to cooperate with me here and replicate what just happened. Hopefully it does, where we see a request timeout. I love it. I love when Packet Tracer cooperates with what I'm trying to show and prove, right? So remember, we didn't have the MAC address in our ARP cache for switch 2, 192.168.1.254. And so why is the first packet timeout? Well, because the ICMP packet times out because I don't have the layer 2 information. I don't know how to get to the layer 3 address, right? And so the first ping times out. But then I get a response back because we found the owner, switch number 2, and switch 2 replies back to me and says, sorry, I didn't want to run the ping command again. I wanted to run the ARP-A. And switch 2 says, oh, here's my layer 2 information. And remember, layer 2 is going to help me figure out where to go to get to switch 2. In other words, I know how to get to switch 1 because from a layer 2 perspective, I know the MAC address of switch 1, right? But do I know the MAC address of switch 2? So I get to switch 1, and now I need to figure out where do I go to get out, what port do I go to get to switch number 2? And so if we were to look at switch number 1 and say show MAC address table, the MAC address, let's take a look. What was the MAC address for switch 2? Well, it ends in 6 alpha 31. If I come on to switch 1, well, look at that. 6 alpha 31. It says go out fast Ethernet 01, which is that link right there. And so at layer 2, this is how we kind of find our way through the switched environment to make it to the node with the layer 3 IP address of 192.168.1.254. Now, what else is out that port? What else will PC1 need to come out that port right there over to this switch to get to? And that's the node that ends in Baker 501. And that has to be PC2. And let's see what would happen if I tried to ping PC2 192.168.1.2. Now, you'll notice it goes through right away, but that's because I know how to get here and I know how to get over to switch 2. So if I come to switch 2 and I say show MAC address table, because I want to see the MAC addresses, That MAC address we were interested in, Baker 501, over here, and of course, it doesn't have what we expect. And it looks like PC2's MAC address is going to be some other value. So again, I was hoping that Baker 501, that we were going to be going out that port to get over to switch 2 to get to PC2, but we'll leave that there. Let's see what shakes out here. So again, I can ping PC2, I can ping switch 1 and switch 2, so everything works great there. Now let's go ahead and check PC2's connectivity. So can it ping 192.168.1, whoops, 168.1.1? Can I ping PC1? I can. Can I ping switch 1, 253? And again, this would indicate that I don't have the MAC address, that I need. So the first packet times out. And then can I ping switch number 2 at 254? And it looks like the MAC address for the MAC address for switch 1 and 2, PC2 didn't know about. If I say ARP-A, you can see I now know 3 physical layer addresses, one for PC1, one for switch 1, and one for switch 2. And so now let's come back to switch 2, because it looks like, and I want to see, because what I'm looking to see here is I'm checking to see if Baker 501 is not showing up over here. And we should see that MAC address. And again, this may be a packet tracer thing, but we should see the MAC address for PC2. Another command we could use is ipconfig-all. And if we spell ipconfig properly, ipconfig-all, we'll see, okay. So what it's actually showing is the MAC address for PC2 is actually 4918, or it ends in 4918. Which is what we're seeing here, which is out fast Ethernet 02, which, interestingly enough, we don't see that MAC address. And now the MAC address shows up, 4918. Okay, so we had a little something going on here with the activity. So now I do see the MAC address for PC2, and that MAC address is 4918. Back here on PC1, if I type in ARP-A, and there we go. So we see 4918 there. We now see it here on switch 1, telling me to go out fast Ethernet 01. And when we get over here, it says, well, if you want to get to that layer 2 address, you go out fast Ethernet 02. And then we would get to the PC who says, yeah, that frame is for me. And then you peel off the layer 2 information and look into the layer 3 information and say, yeah, that is my IP address, 192.168.1.2. All right, so we pinged the IP for PC2. We pinged the address for switch 1 and switch 2. And you could also use the ping command on the switches, which is true. All the pings should be successful. Now, we talked about remote connectivity, right? But what we could also do, or try to do, which soon here, is how to manage these switches. Right? So now we've got the connectivity set up. How do you think we might set the switches up to allow us to telnet to them? So what if I said telnet 192.168.1.253? It's just going to come back and tell me connection closed by foreign host, because we now have some additional configuration work we need to do. But let's find out about that 5%. And was it the banner? It just popped into my head. Did I put a banner on? And that's exactly what it is. It's the banner message. So let's type in Cisco, and let's go into privilege exec and type in class, and then let's get into global config, and let's say banner MOTD, and we'll just put in anything in our banner here, and we should get, and boy, it actually wants me to type in that exact message, MOTD. All right, so let's go back up here. And where's that banner MOTD message at? All right. So it's trying to reinforce authorized access only violators will be prosecuted to the full extent of the law. And that gave us the 5 points that we were missing, so we would save our config. All right, well, we talked about remote connectivity, and again, we're setting ourselves up here to begin to manage these remotely, and these being switch 1 and switch 2. All right, so we looked at a lot of additional information in this activity that can help us kind of hunt things down and to maybe troubleshoot some things. We looked at the MAC address table. We looked at logging synchronous and what that is going to help us with when we're connected to switches as well as routers. All right, so that is going to do it for this Packet Tracer tutorial implementing basic connectivity, excuse me, Packet Tracer 2.7.6. Thank you so much for watching, and I hope to see you in the next video.